in this example we're going to use the method of partial fractions in order to turn this into an integral that's a little easier for us to calculate. So the goal is to rewrite this, it's already factored, so that it's a over x minus 1 plus or minus, well, we'll always use plus, b will come out negative if it needs to, b over x plus 2 dx. So that's our goal. So the key is finding a and b. What you want to do is think about what you would need to do to go the other direction. Well, we'd find a common denominator, and then we'd add them together. So, in finding a common denominator, we'd multiply this guy here by x plus 2 over x plus 2. We know what the denominator is, so all we care about is the numerator. So, I'm going to take that a times x plus 2 and put it right here. And here, this would be b times x minus 1. Now, I'm not writing it in there, but imagine this being over the common denominator. This is what's going on in the numerator. We need that to be equal to 9. Now, depending on how complex our system is, there's going to be different ways that we can solve this. This one's not bad. There's a nice quick way. What I'm going to do is I'm going to zero out one of the terms. So, in other words, if x were to equal negative 2, this term would be gone, and I'd get b times negative 2 minus 1 equals 9. So that gives me minus 3b equals 9, or that b has to be negative 3. This is a very slick little method, and when it works, it's a lot of fun because it's so nice and easy. If x equals 1, that zeroes this out, and we get a times 1 plus 2, and that equals 9. All we're doing is zeroing one part out at a time. This might not work if you have 3 pieces, so we'll look at one of those later. So that gives us 3a equals 9, or that a equals 3. So here's our new integral. 3 over x plus 1 plus a negative 3 over x plus 2 dx. That's really the biggest part here, because these are not bad integrals, these are just natural logs. You could do it with u substitution if you wanted to check, but remember the constant can come out, so that first one is just 3 times the natural log of the absolute value of x plus 1. Again, if you're not sure, take the derivative, you'll get right back to here. Minus 3 times the natural log of the absolute value of x plus 2. And then we'll put a plus c at the end. Now, you're going to see different things from different solution manuals, but one thing we can do with this, because we can use properties of logs, I can factor a 3 out, and then I'll have natural log, imagine that 3 not there, minus another natural log. That can be rewritten as the natural log of the absolute value of x plus 1 over x plus 2 plus c. So you might see the answer in one of 2 ways. They're both correct. So I don't want you to think one way is more right than the other.